Okay, let's copy this over. Okay. Okay. Okay, 140. Okay. Right. Oh, it's not going to fit. All right. Let's start. 140. Let's just get the answers up here as well. Okay. Right, no answer for 140, of course. A company produces cell phones as that cost function where C is the cost in dollars and X is the number of cell phones produced. How many use a cell phone in 1,000? Minimize this cost. So the derivative dc dx would be 2x minus 1,200 equals 0. So that would be x equals 600. 141. So the maximum height is what we want now. So that's minus 9.8t plus 60 equals 0. So that is 60 divided by 9.8, which is about, well, it's 300 over 49, which is roughly 6.1 seconds. Let's check the answer for that one. Yeah, that's right. And do we want that? I guess we want the height as well. So just by subbing that answer back in, minus 4.9 times the answer squared plus 60 times the answer plus 5. So that would be 9245 over 49. That seems a bit big. 188.7 meters, but it's correct. Okay. For the following exercise, consider the production function given there. 142. Find when the maximum, local and global, so that would be this one here, around about this here, occurred. So the derivative, okay. The bottom squared, the bottom times the derivative of the top minus the top times the derivative of the bottom. That needs to equal 0. So t squared, 25t squared, 25t squared minus 50t plus 16 times 25 is 400 equals 0. And the solution to this quadratic is imaginary rats. The bottom squared, the bottom times the derivative of the top minus the top. Oh, I missed the t. So that's a t squared then. Okay, so that quadratic is wrong. Okay. 25t squared minus 50t squared is minus 25t squared plus 16 times 25 is 400 equal to 0. So if 4 years. T is 4. So that would be, and the gold rush began, I guess, started 1848. So that would be 1852. That's the year. And then the gold. So if I just put 4 into the original, 25 times 4 over 4 squared plus 16. So that's 25 over 8 million ounces. Okay. The minimum, yeah, okay, so we're going to have to check the ends. Because there's no local minimum, except maybe possibly -4, but we'll have to look at the ends. Okay, so looking at the ends, g of 0 will be 0. And g of 8 40 is the maximum, yeah, okay. But that's not 0. So global min in 1848 of 0 ounces. But I don't think there's any local min. Let's see what the answer is. Fortunately, it's an odd one, so we have it. The global minimum was 1848 when no gold was produced. Yeah, it's not local. Okay, good. 144. Find the critical points max and min for the following piecewise functions. Okay, let's just check all the key points. So at 0, we have 0. At 1, we'll have -3. And at 2, we'll have 0. And then the derivative, 2x minus 4 equals 0. That means x is 2, so can't be that, because that's outside. And then the second one would be 2x equals 0. Again, that would be outside. So this would be a global max, I guess. And this would be a global max. And this would be a global min. I can't really plot this, so I'm not sure how to plot piecewise ones, but let's see if I get 145 correct. 145. So, okay. I want to check at 1. 1 is 2. But when we go to -infinity, we get infinity. But we could have a global and local min. So let's see. 2x equals 0. So that's 0, 1. That looks like a local min. And then 2x minus 4 equals 0. So that x is 2. 2 squared is 4. 4 minus 8 is -4. 2, 1. Okay, that's a global min. Also a local min. Since that's at 1, it must mean that this is also a global min as well. No global max. No global or local max. Oh, am I right? Let's see. 145. Absolute minimum at 0 and 2. Global local minimum at 0 and 2. But a local max at 1, 2. Oh, I forgot about 1, 2. That's a global max. No, it's not. 145. Local max. Local max. Local max at 1, 2. 1, 2. A global max at 1. A local max at 1, 2. Go try and draw it. X squared plus 1. Okay, and then x squared minus 4x plus 5. Okay. And then it transitions at 1. So, it is a local max at 1, 2. I would have, interesting. I would have missed that. Very interesting. That's a local max. Very interesting. I like it a lot. Tough one. Very tough one. Okay, good. Very good. Okay, 146. State the following exercise. Find the critical points of the following generic function. Are they max, min, or neither? Okay, so this would be when 2ax plus b equals 0. So that would be when minus b over 2a. And then you just sub that in. So that's a times b squared over 4a squared. So 4a plus bx minus b squared over 2a plus c. So that would be 2 over 4. So I think it would just be minus b squared over 4a. And it would be a global min. A global and local min. I think we had a question like this earlier. Okay. I maybe just want to double check that. Actually, I can do that right here. ax squared plus bx plus c. Okay, derivative, simplify, solve expression, solve, sub, minus b over 2a. Simplify basic. Oh. Oh, minus b over 2a. Minus b squared over 4a plus c. Yeah. Okay, and then lastly, 147, if I can squeeze it in here. Bring down the power. Reduce the power by 1. Okay, for that to equal 0, so that would be when x is 1, and you would have a 0. A is more than 1, so it's a positive. But would it be max or a min? The second derivative is a times a minus 1 times x minus 1 times a minus 2. But that's also 0. It's keep going to be 0. It's going to depend on the a. I think it's a local and global minimum when a is even. And it's saddle when a is odd. from the shape. No max min if A is odd, correct. Minimum at X is 1 if A is even. Hurrah! Success. And that's the end of that exercise.